Next, I will introduce this workpiece, which has a 3D model drawing. The 3D model drawings are already on this USB drive. Let's first copy this 3D drawing into the computer. This is the program just made. You can save it if you need it. Create a new project. We copy the 3D file in our computer. Copy to the desktop. Alright, let's return to the software. You can't export the 3D file in the program. It can only be exported in the graphic. There is an input and output in the graph. The input and output model is this. Choose the third one. Look for it on the desktop. Our software is supported IGS and STP format only. This drawing is IGS format. Then we switch jigs to find it. Select the file and double-click. It is importing. OK. This drawing is our product. This is it. The 3D drawing has a coordinate system yet. It's already built by designers. This coordinate system is not good. It's inconvenient for us to conduct measurements. We can modify this coordinate system. It will be more convenient for our measurements. Why it is hard to measure? Because this one is at the wrong angle. There's a tooth hole, so it doesn't work well. We normally move to the big hole. So how do we? You see, the graphics mode has a coordinate system. X-axis is red, toward the right, Z-axis is toward up. The Y-axis is toward back, right? So we can see that the coordinate directions in the drawings and software are consistent, right? We can shift the coordinates of this drawing to the center of this large hole. First of all, you have to choose a probe. I want to move this Z coordinate to this place. I must get the data of this Z-axis coordinate. Then I will take a point on this surface. Double-click the element point. Let's flip the model over first to facilitate point selection. We click this little window. There is a small hand icon. Let's move it slightly. OK, we get a point on this surface. Here are the data for X, Y, and Z, so I know Z coordinate now. It is 34.7655. Click Modify, then Transformation. Look at this place. This is translation, right? I had knew what the data of this surface for z coordinate. Copy it. Remember, here's a detail. That data is positive on this side. If we paste it over, we need to change it to a negative number. Because we need to move the z-axis upwards, must be changed to negative number. If it is a positive number, the z-axis will move downwards, because the 0 position of the z-axis is at the highest point. OK, click Approve. You see, the coordinate system has moved. You point this surface again. What is the coordinates data? 0.000. See here, is it on this plane? Yes, it is. Good. The coordinate has been moved to this plane. What should we do next? We also need to move this coordinate to the center of this big circle. We double-click this circular element. I need to click this arrow symbol. Look here. It can identify a circle by himself. We can also move this circular ring up and down. We can see the data of this circle now. X-axis is 13.0000. Then let's write positive 13.0000. This is the y-axis is 89.9347. Negative 89.9347. Then we need write positive 89.9347. OK, finished. Click Approve. It was changed. Move to the center of the circle. You can also check whether the coordinates are in the center of the circle. Then we use point. You can see that the z-axis is 0. And we click the circle. Z is 0. And get the xy data. Then this coordinate system has been translated. You can save it. I turn it off now. And I can open it again. Well, this is the file we just modified. Next, we can proceed with measuring this workpiece. Then let's do it now. The first step. Choose probe head. First, measure the plane. Good. Let's play the line again. Finally, make a circle. Good. Finished. Next, we need to establish a coordinate system. Click on the alignment. The first one. First, choose the plane. It has turned yellow. That is, it has been chosen. This color has turned yellow. See 0 origin. Add it. Next is the line. Already turned yellow. Let's just click add. The circle of this circle makes XY origin. Change here to 0. Add. After adding, here's a preview. You see. Then click OK. And click Yes. Then the established coordinate system will be associated with the 3D model. The 3D model will be moved to the established coordinate system. Now we change the mode. Choose automatic mode. Safety plane must be set. This distance 4 mm is OK. Check the safety option. Make the plane as the safety plane. Raise 10 mm from safety plane. Click OK. A blue plane appeared. When executing the measurement of the next element, it will automatically be raised to this safety plane. Now we try to have a pot. First, click on this arrow symbol. Have a pot here. Click the right arrow symbol to run. It will raise 10 mm before passing. You see this is a point. I'll pot next point. Get its data. Then click the right arrow. It will move here to point this place. It is as same as last process. Make a point here. Good. If you want to measure a circle, choose the circle element. This circle. Make the point you wanted. Automatically take points evenly on this circle. Click to run. This is over. Next, we will determine whether the dimensions we just measured are qualified. Find the corresponding inspection element in the tolerances. For example, line 1 to the circle. What is the distance of the line to the circle? You can see the measured result. 84.1405 millimeters. Set tolerance for it. There are a plane distance and a straight line distance. We choose a straight line distance, right? Set the size of the product, 80.55. Then positive tolerance 0.2. Negative tolerance 0.2, then judge the measure result. Within the tolerance range, it is green and is judged as qualified. Then click OK. Choose the format of report, then click Built. Go to Desktop. (212) file. If there are multiple measurements, they will all be displayed here. Then you can print it out.